Okay guys, so the notes for today is going to be just one more method of factoring. It's a special type of factoring called difference of squares, and you use this method when there are only two terms and there is subtraction. Okay, so it has to be two terms and it has to be subtraction for this shortcut factoring method to work. So here's how it works. So let's say, for instance, you have a perfect square. Okay, so that would be like 16, 25, 49. All those numbers you can do the square root of. Then you have subtraction. Then you have another perfect square. Again, 4, 16, 25, 49. If you have an expression that looks like this, you can factor it by doing the square root of the first term, which in this case, the square root of the letter, guys, would be A, and the square root of the second term, which would be B, and then one is always a plus and one is always a minus. Looks kind of weird in notation form, but it gets a little easier as we go through and do some problems. So let's take a look at some examples here. So you could see we have two terms and we have subtraction. When you see that, you want to see if you could do the square root of both terms. If you can, they're perfect squares. So the square root of x to the second power is x. So that's a perfect square. The square root of 4 is 2. So that's a perfect square. So what you do is you can write it right away in parenthesis form. And then you could take the square root of the first term is x. You put it here. The square root of the second term is 2. You put it here. One is a plus, one's a minus, and there's your factors. And you're done. Same thing for the second one. So if we do the second one, we can do the square root and just look to see if it works. And do the square root of 1. So both of these are perfect squares and there is subtraction. So I could do the square root of 121, r squared is 11r. So I put that here. The square root of 1 is 1. And again, one has to be a plus, the other has to be a minus. And there's your factors, just like that. The third example, again, there's subtraction, and make sure that these are perfect squares. The square root of 169, x squared, is 13, x. The square root of 49 is 7. So one is a plus and one's a minus. And again, it works because we have perfect squares and subtraction. If you can't take the square root of it, you can't do this method. It only works if you can do the square root of the number. So look at the next example. You can do the square root of 100x squared. That's 10x. You can do the square root of 25y squared. That's 5y. And then again, it's always one's a plus and the other is a minus. And there's your answer. Now here, this is what I'm saying. You can't do the square root of 50 or the square root of 8. The square root of 50 is some decimal, so that's not going to work. So what we're going to have to do, though, is first with GCF, so put a star here. You have to do the GCF first, and then let's see if we can break it down. So the highest number that'll go into 8 and 50 is 2. So we're going to take out and divide a 2. So the 2 will go on the outside, and that'll leave me with 25x squared minus 4. Now from there, can you do the square root of, now just look at the 25x squared and minus 4. Can you do the square root of this? Yes. Can you do the square root of 4? Yes. So now this gets split up into 5x, because that's the square root of 25. Okay. And then plus 2, that's the square root of 4, but there's a plus and a minus that goes with it. And then you bring down the GCF and put it back in front. So that whole thing, this whole expression, is fully factored form. So again, you can only do it if you can do the square root and there's subtraction. So like here again, guys, 27x squared minus 48. You can't do the square root of 27. You can't do the square root of 48. But there is a number that goes into it. It's a little harder, but 3 will go into both of these. So if we divide these by 3 for our GCF and we put that out front, that'll leave me with 9x squared minus 16. Then you look at what you're left with, okay, after taking out the 3 by division. Can you do the square? Because there's still subtraction and 2 terms. Can you do the square root of this? Yes. Can you do the square root of this? Yes. So then that leaves you with 3x plus 4, because the square root of 9x squared is that, and 3x minus 4. And then your GCF of the 3 just drops down, and there is your final answer. So it's all a matter of picking out if you can do it or not. Let's look at this example here. Down at the bottom, right away, I know you can do the square root of 49 and stuff, and you can do the square root of 25. But because there is a plus sign, you can't break this down. This rule only works for subtraction. So when you can't break it down any further, okay, there's nothing to break down, we call it a prime. Because the only number is 1 that'll go into it. So if there's a plus sign, even if they're perfect squares, you cannot do the shortcut. It has to be minus. So just a few more on the back. Let's take a look onto the back here. Okay. Now this, you notice here, guys, okay, it is not x squared anymore. All right, put a little 1 in front, even though they have a 1 there, they're not going to write it. But you can do the square root of any even exponent. So over here on the side, let's put a little star. And I'm going to show you what I mean. So we can do, we said x squared. The square root of that is equal to x. That's what we've been doing. All of them been x squared, so x times x is x squared. If it's an even number, look, x to the 4th, you can do the square root of that because it's x squared. You just kind of cut it in half, guys, right there like that. Same thing, if it was x to the 6th, you can do the square root of that, which makes x to the 3rd. All you have to do is kind of cut the exponent in half and it'll work each time. So let's take a look back at this example. For this example here, it has 1x to the 4th minus 100. You can do the square root, like we said, of x to the 4th. You could also do the square root of 100, and there's subtraction. So when you split this up, guys, you're going to get x squared plus 25 is one of the factors, and x squared minus 25. Oh, sorry, not 25, is it? Duh. Sorry, the square root of 100 is 10. So let's change that. And x squared minus 10. And you're done. So don't do what I did. You cut the exponent in half like that, but the number you have to actually take the square root of. Let's try another one. Let's see. Can you do the square root of 4x to the 4th? Yes, we can. That would be 2x. Can you do the square root of 25? Yes, you can. That would be 5. And there's subtraction, so we can do the shortcut. So, but the thing is, it's not 2x, it's 2x squared because it's to the 4th power. So then that would leave you with 2x squared plus 5 times 2x squared minus 5. And there's your answer. Let's try 2 more examples here, and then I'll have you try a couple. Can you do the square root of x to the 6th? Yes, because this is an even exponent. Like I said, it'll be x to the 3rd. So we'll get x to the 3rd. The square root of 16 is 4. So x to the 3rd minus 4. times x to the third plus 4. Now again, it doesn't matter if you put the plus or minus as long as you have one of each. Last example here. Okay, if we do the square root, let's see, can you do the square root of this? Yes. That is 4x squared, and the square root of 9 is 3. So one is going to be a plus, and there's subtraction. So one will be a plus, and the other will be a minus. So pause the video here for a minute and try these, and we'll give you like 3 minutes to give this a shot, 3 or 4 minutes. Try factoring these based on what we just did. Okay, so hopefully you paused the video, and so looking at these guys again, this is a difference of squares, so you can do the rule. So it'll be x plus 3 and x minus 3, and all I did was the square root of those two terms. Okay? Here, you can do the square root of x squared, but you can't do the square root of 10, and even if you could, there's still a plus, so this is one of those examples of prime where we can't break it down any further. The top one here, first thing is I can't do the square root of 2 and I can't do 72, but I can divide them both by 2. Always look for the GCF as much as you can, first thing. So if I divide by 2, that means 2 goes on the outside, and that'll leave me with x squared minus 36. Then you look at what is in the parentheses and you ask yourself, can you take the square root of both of these terms? And the answer is yes, and there's subtraction. So when I do the square root of x squared is x, the square root of 36 is 6. So one is a plus and the other is a minus. And you bring down the 2. And this whole expression is your final answer. And last but not least here, looking here, can you do the square root of x to the 4th? Yes, because it's an even exponent, so that's x squared. You could do the square root of 81, which is 9. So one will be a plus, and the other will be a minus since there's subtraction in the problem there. Now this one is just a little trickier. I wanted to see if anybody could pick up on it. This one here is another difference of squares. Subtraction, perfect square. Not this, because there's a plus. So this ain't going to change, okay? Don't do anything with the plus. But here, you have to do the square root of both sides. So this would actually end up being x, that's the square root, plus the square root of 9 is 3. And then you would do a minus. They always come in pairs when you're splitting these up for the special rule. This x squared plus 9 does not change. The rule, okay, the shortcut only works for if it's minus. So this is your final broke down answer in completely factored form. So your goal is to try to break these down as much as possible. Your classwork today, for the rest of class, okay, it's going to get turned in as you are going to be given this cut and paste activity. Okay, so you're going to want to start, first thing is you'll grab scissors and you'll be cutting out these pieces, guys. Then on each of these pieces, you could see there are some factoring problems. This is a puzzle, guys. Now, first thing to give you a hint, okay, all the letters should be facing, you're going to cut them on here, they should all be facing upward, clearly, okay? Now, where are you going to put them depends, so don't start gluing them down right away. You need to solve each of these. So for instance, like this one, for this P, you need to factor x squared minus 3x plus 2. Well, that factored makes numbers that add to this and multiply to 2 are x minus 2 and x minus 1. So what you do is, on notebook paper, you'll be factoring like that. Okay, do that on notebook paper. And then you go in and find that in factored form. So as I'm looking through my squares, I'm looking for x minus 2, and x minus 1. Somewhere around here. And if I don't find it, then that means nothing touches on that area. Doesn't mean I factored wrong, it just means that's an outsider. So I don't see it anywhere on here, so I know right away this is probably going to be on the outside somewhere. Now I don't know where, so I'm not pasting it down here, but I could not find these factors anywhere on any other square. So that's the idea. So anything that is in this form or this form, now I'm going to start factoring this. So I'm going to copy this one on paper, factor it, and then find the piece that would match up with it. And you put that underneath it. I suggest waiting, guys, and getting all of your pieces cut out, then factoring each side and moving them around. You are going to staple and paper clip anything together that's not done, but you should be able to finish between now and the end of class, and you're going to put it into the period bin to be collected. So scissors and glue are out, and you're going to do all your work on notebook paper. And then again, you're only gluing down final pieces as they match up. Good luck! And don't forget, Delta homework is due Tuesday.